Hi guys, so I am Sara Talathi studying in Vishwakarma Institute of Technology and I am making this video for my DBMS assignment. So now I would be sharing my screen. Okay, so we'll start with Unit 1, the introduction. So database, what does actually the data means? It is known for the fact that can be recorded and have that to be implicit meaning. A database is also a collection of related data. Let's for example consider the name, telephone numbers and address of the people you know. You may have been recorded this data in an index address book or you may have stored it on a diskette using a personal computer and a software such as DBase 4 or 5, Microsoft Access or Excel. This is a collection of related data with an implicit meaning and hence it is a database. So basically through this slide, basically data refers to the fact that can be recorded and have meaning to it, and a database is also a collection for related data. So as I told about the example with names and phone numbers and address people which are related, there are many other softwares which people use to store and put it in a systematic way, that is Microsoft Access and Excel, and it is basically used to organize and give meaning to that information. So let's move on. So database management system. So a database management system is a software suite that enables users to create and manage and interact with databases. There are several key functions for that. First, the DBMS allows the users to specify the types of data, the structure, for example, like tables, relationships, and the constraints like data integrity rules for the database. Second was constructing the database. This involves storing the data on a physical storage medium like a hard drive or a cloud storage in a way that it is managed and organized by DBMS. Third was manipulating the database. So there are the three main construct: defining, constructing, and manipulating. The third one is manipulating. The DBMS facilitates operations such as querying, updating, and generating reports. I'll explain you one by one more in detail. So querying basically means retrieving the specific data based on the user request. So whatever the user's request for the data, the querying does that work. Modifying the data to reflect changes in the real world scenarios, like the mind world or mini world is used, that is like updating. Third was generating reports, creating the summarized or formatted outputs of the data for analyzing of presentations, or basically the converted mini world which you have done by using updating. Next, DBMS allows users the following tasks: data defining, data updation, data retrieval, and user administration. So data definition involves creating and modifying or removing the structure that organizes the data in a database. Data updation refers to of insertion, modification, and deletion of the actual data stored in the database. Data retrieval allows the retrieved data from the database for various application users. Users administration manages user registration, ensuring the data integrity, enforces the security, handles concurrent access, monitors performance, and recovers from the system failures. Next was database system versus file system. So storing information in operating file system is a major drawback. So data redundancy and inconsistency, difficult in accessing data, atomicity problems, security problems are the major problems due to the versus file system. So what is the need of it, or what are the benefits of having DBMS for it? Is for first is ease of accessing data and second is storage and management of the data. So first, ease of database means the DBMS eliminates the redundancy by controlling data access to users as well as to the who the ones are going to use it in further need, to easily retrieve the specific data they need without requiring custom code or application. Second, which was storage and management of the data. Unlike the file system where data must be mapped into objects, DBMS allows direct storage of the data as objects, improving organization and management. Basically, it directly is stored into in a form of a subject. Like even if you are studying a course, there are proper subjects in the inside the courses which you have to learn. So basically, the storage and management of the data works like that. The third is easy and efficient file management. Fourth is avoiding duplicates and redundancy and concurrent data accessing. So basically, easy and efficient file management means that DBMS indices data based on attributes, improving retrieval speed compared to the traditional file system, while requiring the entire database to be searched. It is because of this DBMS, it helps us to find the details very easily. Avoiding duplicates and redundancy. Through data normalization, DBMS prevents the storage and redundant or duplicate data. Concurrent data accessing. DBMS allows multiple users to access the data simultaneously without inconsistency using the ACID, that stands for Automacy, Consistency, Isolation, and Durability principles to manage the concurrent operations. So ACID is basically an operation, that is automacy, consistency, isolation, durability, which gives the concurrent data accessing to the other users. Next was ACID properties in DBMS. As I said, ACID stands for automaticity, consistency, and isolation durability. Here they have just explained in short details. So now let's talk about the advantages of DBMS, which is controls the database redundancy. So basically, it can control the redundancy by storing all the data in a one single database. Let's suppose if you are making an tourism management system where you have to collect a lot of information about different places. There you create only connect the different database in a one single database, that is recorded data, and it is placed in the database. Data sharing in DBMS, authorized users of an organization can share the data amongst the multiple users. Easy maintenance because of having only one database, or easy maintenance has been done. Reduces time, like as I said, the example of tourism, it allows the user to get only on one platform and search about it rather than going on multiple platforms. Backup, it provides backup and recovery subsystems which creates automatic backup of data from hardware and software failures and restore the data if required. Multiple user interface, it provides different types of user interface like graphical user interface, application program interface, and etc. These are the some advantages of having DBMS. So first we talk about the need, what was the DBMS, and now we learned about the advantages of it. Now let's see why database system, what are the database system application. Banking, airlines, universities, and telecommunication. One of the example I recently gave was about the tourism too, but let's see what other applications are there. So banking, for customer information, accounts and loans and banking transactions. So basically, if a person has taken any, there's an account in a particular bank, how much loan. So if a database is created for banking, it would be so easier for the organizer of the bank to, if let's suppose a customer comes and wants to, has forgotten the some like come to the bank and forgotten the account number, he could easily find it by other details. Airlines, for reservations and schedule information, airlines were among the first to use the databases in a geographically distributed manner. Terminals situated around the world access the central database system through phone lines and other data networks. So there are many satellites also which connects throughout the world, connects the different terminals together to know the schedule if any flight is getting delayed. Universities, for student information, course registration and grades. As I said, like for the tourism, how people are gonna register in one place. Well, similarly, the university keeps the student information in a one database, so they can just find the student name and get all like its information and which course he is in and which grade he is in. And last was telecommunication. There are some more examples: finance, sales, manufacturing, and human resources. Manufacturing is one of the key over here, that for management of supply chain and for tracking production of items in factories, inventories of item in warehouse stores, and orders for items. So if a database is for the small shop like the local shop, then it is very easier for them to keep it with the hand, like handwritten they can keep. But let's suppose if it gets bigger, like for the industry, let's suppose it is very difficult for them to even remember how many supply chains they have created, or which factories and warehouses are having how much of stock. So it is very easier to have the database for them. Now let's talk about the data abstraction. For the system to be usable, it must retrieve the data efficiently. The need for efficiency has led to designers to use complex data structures to represent the data in database. As I said, the company gets bigger, the logic also for the database needs to be changed. So there are three types of level for there are several levels of abstraction, and the three we are learning are physical level, logical level, and view level. So this is logical. So basically, if we talk about the physical level, the first one, physical viewer is user by user, which goes to the logical level, the three levels of data abstraction. So the physical level is the lowest level of the abstraction. It describes how the data are actually stored. The physical level describes the complex low level data structure in detail. The next higher level of abstraction is logical level, which is what the data are stored and how and where it will be stored. In view level, only the part of an entire database is there. It is like an overview of the database. Now let's talk about the DBMS terminologies, that is data independency and instance, database state or snapshot, and schema. So this is what we learned about the technologies, like how overall design, how the information is inserted and deleted, how like basically how the DBMS database is being created. Let's talk about now the architecture of it. Types of DBMS architecture. There are three tiers of architecture. First tier of architecture talk directly available is directly available to the user. It can directly sit on DBMS and use the user client can use it, server and the database all present in the same machine. For example, if you want to learn SQL, we set the SQL server and the database on the local system, not on the client based system. If the client based system wants to be done, it is done on the different architecture. So this is the centralized system with a single user disk. You can see over here we have CPU, disk controller, sprint controller, and tape drive controller. A system bus is connected to all. A disk controller are connected to two disks. A print controller has a printer, and two tape drivers are there with the controller, which is all going to the memory controller to the memory. The second tier was about the client server model. As I said, different like one network is there, but different clients can be using having one server and multiple clients for it. And the server side is responsible for providing query processing and transaction management functionalities. In DBMS, there is an advantage of having this type is to maintenance and understand on easier level, which is compatible existing system. However, the model gives poor performance when there's a large number of users. So if like suppose there are number of 10 or 20 servers at a time, it can handle, but if it exceeds a certain amount of client, it may crash at a point. So for that, the third tier was created, which was a layer between the client and the server. The client does not directly communicate with the server. Instead, it interacts with an application server, which further communicates with the database system, and then query processing and transaction management takes place. This intermediate layer acts like a medium of exchange partially processed data between server and client. This type of architecture is used in the large application. As I said, the first tier is for the user, the second is for the client, and third is acting like a medium between the client and the server, and this is also used for large web application. The advantage of having the third was enhancing scalability, data integrity, and security. Direction. Thank you.